So, which of these points is our starting point? -2, 3 or 1, -3? Devin?
1, -3.
1, -3. Is that on the left side of our graph?
Oh,
-2, 3. Start with the leftmost. If you forget which one is your left and right, just hold up your fingers like this. L is left, right? So we're going to start at -2, 3. And our rise, which we're going to count first, is going up or down until we hit this second point, or at least until we're in line with this second point. So from here, do we need to rise up or down? We're going to go down. Let's count it out. We got 1, 2, 3, 4, 5, 6 spaces down. We're directly in line with that second point. Our rise is going to be 6. So we can set that up. M is equal to rise over run. So the rise that we found was what again? 6. Everyone good on rise so far?
yeah.
We start with the left point, and then we see whether we go up or down. This time we're going down. Yesterday we had to go up, right? We'll see what that makes a difference of in a second. From here, are we going to run to the left or run to the right? If we want to land on this point here, are we going to go to the left or the right? Anybody? To the right. Take a look. If we're here and we want to end up here, we got to go to the right. 1, 2, 3 spaces to the right. And we see there's our little slope triangle that we draw, or that we created, I should say. Just like that. So our denominator, our run, is going to be 3. But this is where things get a little bit different. Because our rise of 6 was downward, our numerator is not just going to be 6, but it's going to be what? -6. I heard someone say it up there. That's absolutely right. That's why we always start on the left, because we determine our direction. It's going to help us figure out whether we have a positive slope or a negative slope. So we're going to add in here, when we rise down. I know it sounds ironic for us to rise down, because rise typically means we're going up. But when we rise or change our y in a downward direction, our delta y, or our change in y, is going to be negative. We're going to cloud that up so we don't forget. Can we simplify -6 over 3 at all?
Yeah.
Yeah, how many times does 3 go into 6? 3 times, very close. 2 times. But what's a negative number divided by a positive number going to give us? A positive or a negative? A negative. -2 is our actual slope here for this line. Yes, go for it. Yeah. Come on and go ahead. The slope of this line is -2. Now, if that's a little bit confusing, let's put this in a little bit more of a visual outlook here. Let's see how to tell if your slope will be positive or negative. Go ahead and draw two little coordinate planes. You don't need any of the notches, just the x-axis and a y-axis. So when we introduced slope yesterday, we talked about where we had heard of slope before, right? You guys mentioned the game slope, where you're a ball that's kind of rolling down a hill. We talked about skiing, where you're skiing down a slope. Talked about the slope of a mountain. If you're hiking uphill, that's a steep slope, right? So whenever we see a line that's going upwards from left to right, just like this, we're going to have a positive slope. Well, how can we tell that this is going upwards from left to right? Here's what we can do. Just like when you're reading a book, you read left to right. We're going to do the same thing here. Left to right, left to right, left to right. We're going to draw a little stick figure on the left side of our line. There he is. There they are. On the left side of our line. Good morning, Hope. And we're going to determine if this little stick person was going to walk across this line. Right? So if they're going to walk across this line all the way to the other side, would they be going uphill or would they be going downhill? Would they be going uphill, right? So if you're walking up a mountain that is uphill, that hill or mountain has a positive slope. However, if we have a line that goes downward from left to right, it'll look something like that. Now these lines look very similar. They're kind of just flipped around or opposite of each other. We're going to follow this same kind of process here. We're going to draw a stick figure person on the left side of our line. Not on the lowest side, on the left side. And we'll ask that stick figure to walk to the other side of the line. So if that stick figure person walked to the other side, does it look like they'd be going uphill or downhill? Downhill, exactly. You guys are getting it. So when we have a line where our little stick person, good morning Ashley, is walking downhill from left to right, that's going to give us a negative slope. Thank you. Take a few moments to breathe that in. Notice the similarities and differences. How you'll be able to tell just by looking at a graph whether your slope's going to be positive or negative. Once you get that all copied down, we're going to start the second half of this lesson, which is finding slope not from a graph this time, but from a table of points. And this might even be a lot easier for some of you. We'll see. So let's say we got a table of points. Let's do something like this. Need more space. Move this down. It's not a very even table, but it's okay. So let's say our x values are 1, 2, 3, 4, and 5. And let's say our y values are 3, 6, 9, 12, and 15. So our slope is just the change in y divided by the change in x. So if we have all these points listed out, we could just go from point to point and figure out what that change is. So on top of our x row, we're going to write delta x, and beneath our y row, we're going to write delta y. Remember, delta signifies a change. It's represented by a little triangle. Take a look around and see where we're at. Make sure we're all doing okay. That was good. Still getting our tapes written out. What do you guys do? Looks good. Good. So here's what we're going to do. We're going to draw these little arrows. Our first x value is 1. Our second x value is 2. We want to figure out what changed from 1 to 2. Well, how do we get from 1 to 2? We add 1. So we're going to draw a little arrow from 1 to 2. The change there was plus 1. How do we get from 2 to 3? Plus 1. But what about from 3 to 4? Plus 1. And 4 to 5? Plus 1. That is a nice constant change. Our m is equal to the change in y over change in x. This is where it gets tricky because it's flipped from what we see in the table. So all across the top we got plus 1, plus 1, plus 1, plus 1. Our change from x value to x value to x value will be plus 1. That's going to be our denominator. in our slope. Change in x goes on the bottom. That's plus 1. Give me a thumbs up if you see how we found our change in x there. 4 people see. How can I explain it maybe a little better? Where are we getting lost? Maybe it's just Friday. That's more likely. Let's figure out the change in y now. Our first y value is 3. Our second y value is 6. How do we get from 3 to 6? Plus 3. Thank you. What about from 6 to 9? Plus 3. From 9 to 12? Plus 3. 12 to 15. Look at that. It's nice and constant all the way through. Our numerator is going to be plus 3. So I would say leave like this much space and start the little table. Can we simplify 3 over 1 at all? What would 3 over 1 be equal to? 3. There's our slope. M is equal to 3. What happens when we divide a positive by a positive? What's the sign of our answer? Positive, exactly. Just checking. Make sure. Give me a thumbs up if you feel like this way is a little bit easier than the whole rise and run on the graph. Okay, I see a decent amount of thumbs up. That's good. I'm glad this makes sense. On worksheet 13 that we're going to get today, front side we've got some little graphs. The back side we've got some little tables. So we're going to get some great practice with both of these methods here in a little bit. And we'll have tons of time. I'm going to give you guys like another minute to get this copying, and then I got to flip over and finish. All right, we're going to move on. If you need more time, don't worry. We can come back to this. Let's do another example of a table here. Let's set this up. Boom, boom, boom. X on top, change in X above that, Y on bottom, change in Y below that. Let's say we've got for X values 5, 3, 1, -1. Welcome back. And for our Y values, let's say we've got, so that's going to be, let's do 3, 4, 5, 6. Go ahead and get this next table set up here. So let's figure out our change in x on the top. We've got 5, 3, 1, negative 1. So we'll draw a little arrow from 5 to 3. And what operation do we have to do with what number to get from 5 down to 3? Minus 2, exactly. Minus 2. What about from 3 to 1? 3 to 1? Minus 2 again. And from 1 to negative 1? Minus 2. You'll notice as you're going through this worksheet, it's always going to be constant. At least I hope. I'll double check and make sure, but it should be. Yeah, I think it is. So our change in x, our denominator is going to be negative 2 minus 2. How do we get from 3 to 4? 1, is that a plus 1 or a minus 1? Plus 1. What about from 4 to 5? Plus 1. And from 5 to 6, we got plus 1. So our numerator is going to be plus 1 there, that change in y. Personally, I like this way a lot better than the graph. It's easier to make a mistake when you're counting the little tiny squares on a graph, but this is nice and straightforward with the numbers. So if we have positive 1 over negative 2. Can we cancel anything out from the top and bottom with 1 and 2? Definitely not. 1 and 2. But is our fraction, our entire fraction, is it going to be positive or negative? If we have a positive divided by a negative, our fraction is negative. So our slope here would be equal to negative 1 over 2. If we were to graph this, which that's what we'll get to in, I think, Monday's lesson or something like that, we're going to see something just like this, with our little stick person going downhill from left to right, because we have a negative slope. Do one last table and we'll get started.
Wait, started on what?
Worksheet 13.
Oh, okay.
I'm going to zoom out here a little bit. There we go. Good morning, sir. Do you have your little pass thing? Okay. So for our x values, let's say we've got 40, 35, and 30, and 25. And then for our y values, we can do 10, 15, 20, and 25. We're going to do our little arrows here. Now, what do we have to do if we want to get from 40 down to 35? Subtract 5. Good. Thank you, guys. What about from 35 to 30? minus 5, or subtract 5. And from 30 to 25, minus 5 again. My denominator is going to be minus 5. But how do we get from 10 to 15?
Plus 5.
Plus 5. What about from 15 to 20? Plus 5. And 20 to 25 gives us plus 5. So our numerator, positive 5. Thanks, sir. Anybody unsure on how we found our numerator and denominator for our slope here? Pretty straightforward, hopefully. But if you need a little help, let me know. Now, if we have 5 over 5, what would that simplify to? 1. Right? Anything over itself is equal to 1. And a positive divided by a negative gives us a... I'm going to ask that again. A positive divided by a negative gives us a negative. There we go. Remember, positive and a negative make a negative. Different signs give you a negative. If this was a positive and a positive, or a negative and a negative, same signs give you a positive. Therefore, m is equal to negative 1. We've got another downhill sloping line if we were to graph it. Luckily for today, we won't have to be doing any graphing at all.